So look at this shape. What is this shape? This is obviously it reminds you of the square shape, and obviously it is square shape. I think if I hold it like this, then it becomes rhombus. It becomes rhombus, I think. Does it? Actually not. I can do anything with that. So it's like what I used to do is just asking you, what is the area of this square? What is the area of the square? You know, this side is x unit. This side is x unit. This side is also x unit. So when both sides are x unit, so what could be the area? So it should be x squared, no doubt. All right, but okay. When I fold it into halves, I just halve it. Fold it from the midpoint. So thank you very much. It is rectangular. It is a square. It is a body. It's a body. Yes, it's a rectangular. So be very, yes, these teachers are very technically very correct. Thank you very much. This is not a square. It is a square shape. It's not a rectangle. It is a rectangular shape. All right. And I would leave you with a very interesting question after some time. But the thing is, when this, I fold it into, I halve it by just folding it through the midpoint. So how much is the area now? X square by 2. Thank you very much. X square by 2. I know what is happening in the back of mind. And those teachers who are actually working with the area and perimeter in primary grades, if this 10, then 100, and now it is 50. So actually it is x square and x square by 2. Vivek Bhatia ji, sir, give some time. Actually, yes, you can take time. Thank you, Bhatia ji. So this is x square. If I hold it like this, just for a better visibility. So now this side remains x, but this side is x by 2. So what can I say? When you have one side of a square, then its area gets half. This. Now let's talk about perimeter. Thank you very much, Vibhuti ji. Thank you, Khan Bilal ji. Now, if this is x, what is the perimeter of this shape? Obviously, it should be. Yes, you're right. It should be 4x. Yes, you are about to type it. It should be 4x. But when I fold it into halves, just I halve it, then what is the perimeter? X by 2, x by 2. What is that? 3x. The thing is, halving this shape can halve its area, but not its perimeter. All right. So it means that halving it is directly proportional to halving the area. Directly proportional to the area. This fold, but it is not directly proportional to the perimeter. Okay. Now, but this I am halving only one side. Now I have it's both the sides. This side already I have halved here like this, and then this side also I will fold it again through its midpoint. Now this becomes another shorter shape. Thank you, Geeta Pandey ji. Yes, that was 4x earlier, but now, and Ishita Chatterjee ji, it is not 2x, it was 3x, the perimeter. Now I am talking about the area. When I halve it both the sides, then the area is actually 1/4 of the original shape. And perimeter? X by 2, x by 2, x by 2, x by 2. Perimeter is 2x. So means like I am actually taking this, taking the quarter of the original shape, and I'm getting quarter of the area. But I'm taking quarter of the original shape, but I am taking half of the original perimeter. Isn't it very, very sophisticated, effective, efficient example of ratio and proportions? So you can use this shape. It is a powerful shape, don't you know? Okay, and thank you. Yes, thank you, Jins Renaud ji. Thanks a lot for replying. All right, now one more thing. Dear teachers, if this is x and this also x, I am folding 3 units from this side. So means I am actually reducing this side. I'm decreasing this side by 3 units. What will be the area? Earlier it was x square. Now what will be the area? Anybody? I know you will come up with the answers. And you know what happens when I fold 3 units from this side, and I'm saying units and only 3. This side originally was x. Now it is x minus 3 only. And this side is already x. So when x minus 3 and x, so what should be the area? And as somebody said, okay, give some time. So I'm giving some time. Thank you. And thank you, Shweta Rana ji, Maz Ali ji, Mukesh ji, Deepa Sahu ji, Ruby ji, for interacting with us. Though it is not very easy to interact, because there is in between there is interface, but still. So x minus 3 into x, obviously x square minus 3x. Thank you very much, Rajneesh ji. I think Rajneesh Tiwari ji has come up. X and x minus 3, and I'm asking about the area. And when I ask about the perimeter, then it will be x and x, 2x, x minus 3, 2x minus 6. So total perimeter will be 4x minus 6. Okay, sir, there is some time lag. Oh, okay. Okay, Rajneesh ji. I understood. So I'll be a little, slower now. So what is the point? The whole point is, through taking this simple object, we are taking, just using this to give or to make or to create a very good amount of mathematics. Very good amount of mathematics, the algebraic reasoning, the algebraic, manipulations we are doing here. And I folded 3 units from this side. And now it will be further amazing for you if I fold 2 units from this side as well. Thank you, Minakshi Bhatt. Thank you, Amandeep ji. Thank you, Ikna Yasha ji. Thank you, Fatima Ansari ji. Thank you very much. Perimeter was 4x minus 3. Actually, it was, yes, thank you. 4x minus 6, as per my understanding. Thank you, Dhanya ji. Okay, thank you, Kartikeya ji. Now, from this side, 3 units I am folding, and this side, 2 units I am folding. Now this side remains x minus 3, and this side remains x minus 2. So x minus 3 into x minus 2, and you will get the expression for area. And what will that expression, Vanajaji? That expression will be quadratic expression. Everybody, please write down that expression for the area when this side is x minus 3 and x minus 2, another side. I'm waiting. Thank you, Prashant Lalji. How that side is x minus 3? Okay, Ishita ji, actually, because this side originally was x, I just folded 3 units from it. Thank you, Deepti ji. Thank you. So, okay, x minus 3 and x minus 2. Thank you, Priyanka Mendirata ji. The thing is, what I want, I need the standard expression, the standard quadratic expression. X square minus 6x plus 6. Actually, it should be x square minus 7x. Thank you, Ashok ji. Pawan Bhardwaj ji, hi. Ashok ji, it should be x square minus 7x plus 6. Okay, so that is the so from this one single piece of paper, what different things we are doing? We are doing ratio proportions. We are doing linear equations, expressions. We are doing quadratic expressions. We can do even cubic expressions also. Let me show you. This is a cuboidal thing. And when I keep this cuboid somewhere, can you please find out its volume? As I told you, this side is, I have folded from here 3 and from here 3. So this side is x minus 6. This side is 3. This is also 3. Height is 3. And this is x minus 6. And this was already x. Listen, you will get expression for the cube. Means the cubic expression with just one paper. And those teaching polynomials of different degrees, it depends. It makes it very, very effective, a way to communicate this whole idea. Thank you, Santi ji. Thank you. Very effective way to communicate this idea to your learners. Okay, and this is just one piece of paper. And in primary grades, dear teachers, in primary grades, you can, what you can do, you can do fractions. 1/2, half, 1/4, 2/4, 3/4, 4/4. When there are 4/4, it becomes one whole. When there are 4/4, it becomes one whole. Okay, now this is 1/4. Thank you, Yogendra ji. Now this 3, Yogendra ji, like 3 dimension. Yes, thank you very much, Pawan Bhardwaj ji. Yogesh ji, which I am saying, this 3, we can still make it in terms of x, and that will make it 3 degree. So I was telling primary teachers, so if this is 1/4, I further halve it. I further halve this 1/4. Do you know what you will get? You will get 1/8. You will get 1/8. So that's why 1/4 into 1 into half is always 1/8. Okay, this is the multiplication, isn't it so? And so nicely. All right. And when you open this, then how many 1/8 will be there? There will be how many 1/8? 1, 2, 3, 4, 5, 6, 7, 8. 8 1/8 will be there. So the thing is, when you divide any whole by 1/8, you divide any whole by 1/8. Thank you, Harshita ji. When you divide one whole by 1/8, you will get 8. This is the division of fractions. So just with one piece of paper, you can do wonderful things.